Hello, today we'll be talking about developing a probability model by observing frequencies. Hopefully these names start getting a little shorter. So a uniform probability model assigns equal probabilities to all outcomes. So if I'm rolling a dice you can get a 1, 2, 3, 4, 5, or 6. So a uniform probability model. So what are my chances of getting a 1 here? Well, it's 1 over 6. There's only one outcome that I desire over 6 possible. What about for a 2? 1/6 again. Probability of getting a 3, 1/6. Probability of getting a 4, 1/6. Probability of getting a 5, 1/6. Probability of getting a 6, 1 over 6. So this is a uniform probability. All the probabilities are the same for the desired. So it's like saying I have a book, a 50-page book. 25 of those pages are green. The next 25 pages are blue. All right, so what's the probability I'm going to open the book to a green page? Well, it's going to be probability of opening to a green page will be 1/2, because half the pages are green. What would be the probability of opening to a blue page? 1/2, because half the pages are blue. All right, that's uniform probability. The probability is the same throughout. All right, so frequency is just how often one event occurs. So if you roll a dice 10 times and you get 4 3 times, so the frequency of getting a 4 is 3. Say I roll 1 twice, the frequency of getting a 1 is 2, and so on and so forth. I'm not going to do any examples over that, it's just in the lesson, so I'm talking. All right, another look at the probability model is, let's say I have 4 4 7 7 7 9 9 9. All right, I'm drawing numbers out of a hat, and this is what I draw. I draw 3 4s, 3 7s, and 3 9s. What is the probability of me getting a 4? Well, that's 3 over 9, or 1/3. Right? What's the probability of me getting a 7? Well, it's not 7. It's 3 over 9, 1/3. Probability of me getting a 9, 3 over 9, or 1/3. All right? So this is uniform probability. It's all the same chances. But what if I say I drew a 4 and a 4, a 7, 7, 7, and 9, 9, 9, 9. All right, I still have the same number of them, but now my probability of getting a 4 is 2 over 9. My probability of getting a 7 is 3 over 9. And my probability of getting a 9 is 4 over 9. Are those all the same? No, so this is not a uniform probability model. All right, I'm gonna read something right off our little lesson. So you have a scrapbook and you have completed 40 of 50 pages. Each page is part of a spread, and each spread has a left and a right page. 25 pages will have journaling, where you will write to explain what was happening when the picture was taken. On a few of the pages, you have included a souvenir of some sort. 1/3 of the pages have a thin border, and a third has a thick, and 3 have a graphic. So of all of that, it seems pretty uniform, but there's one in there that is not a uniform probability, and that's the souvenirs, because it says exactly, you have included a souvenir of some sort on a few pages. A few is not a number, all right, and that's not uniform throughout. There's not souvenirs on half and souvenirs on the other half. It just says a few. There could be souvenirs on 3 pages, there could be souvenirs on 40 pages. It doesn't say. So that is not a uniform probability model. That would be different between the pages with souvenirs and without. All right, so what if I said what is the probability that a page is not complete? All right, so I said I have completed 40 of 50 pages. All right, so if I've completed 40, 50 pages, how many pages are not complete? Well, 10 are not complete of the 50 pages. So that's just 1/5 of them are not complete. All right, I talked about the borders. So I have, so 1/3 are thick borders, 1/3 are thin borders, and graphic borders. So is that uniform? And how do you know? Yes, because if the probability of me getting a thick border is 1/3 and the probability of me getting a thin border is 1/3 and the probability of me getting a graphic is 1/3, you add those all up and you get 3/3, which is equal to 1, right? And they're all the same. So all the sizes of borders have equal probabilities. So that is a uniform probability. Let me see if there's another one we'll go over. All right, the other thing. And I know this is gonna be a weird video because I'm sort of reading, the questions are real long that I'm going over, so I'm actually reading them. So how many different outcomes are there for a trial to find the probability that a page is complete? All right, so this, I can use the tree diagram and show you this really quickly. So I want to know the possible number of outcomes. That's what we use the tree diagram for in another one. So I'm going to say the book, and I'm going to say complete pages, incomplete. So how many possible outcomes do I have if I did a trial? 2. All right, this has been a quicker video over the developing a probability model by observing frequencies. Most of the videos me just trying to say that over and over. Good luck.